Welcome back to Physics with Miyoshi. We are on a little bit of an angle today simply because I want to explain what many of us as teachers forget because we've been doing it a long time, but that is that you can change the axes of any free body diagram or any axis anytime you need to. So if we have any point, and you can see all over the board up here, I have several points and they have different axes. This one is actually fairly normal, where it's going X and Y horizontal and parallel to the surface of the earth, and this one is quite canted. This one is basically rotated 90 degrees, and this one's even upside down. But the point of it all is to show you that we can really arbitrarily take any point in space and arbitrarily assign it an X and Y direction. In this case, I like to call them X prime and Y prime, but in reality there's no real X axes and Y axes. They're just any X and Y axes that we want. If we look at this figure right here, we can see that our X and Y are parallel to your axis looking at this figure, whereas I am straight up and down according to the weight here. And so if we looked at most free body diagrams, they're going to have a weight component of your the mass and weight component of the object that we're looking at, and so that's why this one's coming straight down. Again, since you are rotated parallel to the x-axis here, you see this is not straight down, but as a different angle. But when we look at any free body diagram and we have an axis that's changed, we notice that if we're usually given that angle it's changed at, and so that's theta here. When I look at my weight coming straight down, I can make this right triangle based on the weight and that angle, and knowing that this is a right triangle, we can see that the triangle here would be, as we know from our geometry, the sum of our angles of our triangle must equal 180, so that would be theta plus alpha plus our 90 degrees is going to give us 180. Well, that means that when we subtract the 90 from both sides, we get theta plus alpha is 90 degrees. Well, here also we have, we know that these guys, X and Y axes have to be 90 degrees apart. That's what kind of defines our X and Y axes. They're 90 degrees from each other. So that means we have alpha plus beta must also be 90 degrees. Well, if alpha plus beta is 90 degrees and theta plus alpha is 90 degrees, then theta and beta must be equal. So beta must be equal to theta. Well, how does that help us? Well, most of the time when we draw a free body diagram such as this, we're talking about our x-axis is usually being parallel to our motion, and our y is being perpendicular or normal to our motion, or to our forces that we're looking at. So here we have a diagram very similar to this over here. Well, theta and now is beta now is theta. So if I look at these as parallel, or x prime, force along my x prime, and the force perpendicular or force along the y prime axis, and I look at my weight, then I can break the weight into parallel and perpendicular components. And the way I do that is simply by remembering that the cosine theta is the F perpendicular, or the Fy prime, over the weight, force of weight, which is, rearranging the equation, I get force perpendicular is force of weight times cosine theta. And the same thing here, when I look at cosine of theta is F parallel over Fw, or the force of the weight, then I have rearranged that equation and I get F parallel, or force parallel, is the force of weight times the sine of theta. And if I always draw my angle the same way, then I'll always have my theta, my cosine and the sine of theta the same. And if I always draw these free body diagrams to match up with my forces or direction of motion, then I'll have a nice, beautiful free body diagram where everything except for the weight, hopefully anyway, is going parallel or perpendicular to my force or to my direction of motion. This is a great way, it's a great tool to use, and just remember that any point in space can have any X and Y orientation that we want. It's just a matter of choosing what's convenient for you, and normally that is parallel and perpendicular to the direction of force or the direction of motion. So hopefully that helps explain a little bit about why we can change our axes, and hopefully you got a little bit out of this discussion. And just remember to look at the picture, make adjustments as you need. Don't just assume that this is always going to be true. Make the picture and go back to your definitions that you know, and then everything will be fine as you start to do more complicated problems. So thanks for tuning in. We'll hope to see you next time on More Physics with Miyoshi. Here is the orientation back the way it would be normally if we were, instead of parallel and perpendicular to our directions of motion.